we need to fill in the blanks that were left out by the printer. So in our title here, it's just trigonometric. Reference angle, the positive acute angle. And on the next line, acute angle made by the terminal side. And down here, example 1, find the reference angle. And then down here, we can now find exact trig function values and trigonometric is, and again here, trigonometric. Okay, so again, sorry about that with the printer, but now let's go back and see what the heck they're talking about. So we have a new vocab word called a reference angle. What in the world is a reference angle? It's the positive acute angle made by the terminal side of angle theta, written as theta prime. You'll notice there's a little apostrophe after your theta here. Written theta prime is the positive acute angle made by the terminal side of angle theta and the x-axis. It's always found with reference to the x-axis. So it's actually pretty easy to do. So in example 1, it says find the reference angle for 218 degrees. So here's where I like to do. First, I draw myself a set of axes. Remember that 0 degrees is always the positive x-axis. And then we go around, that would be 90, that would be 180, that would be 270, and so on. So if I was going to draw a 218 degree angle, you always go counterclockwise, right? So here's 90, here's 180. If this is 180 and this is 270, then obviously 218 is going to land in my third quadrant, right? Somewhere in there. And let's see, 218, probably a little bit closer over here. So this whole thing represents my 218 degree angle. So far, does this make sense? Now, to find its reference angle, all I'm going to do is I want to find this acute angle between the terminal side and the x-axis. That's it. Well, I know that this is 180, right? To get from here to here is 180. And if the whole thing is 218, what do you think I do to find just this measure? I'm going to subtract 180 from 218. Does that make sense? So in this case, I will do 218 minus 180 and get a reference angle of 38 degrees. Let's try it with 294. So sketch out where you think 294 would land. No. You always want to draw, well, where would this land? In what quadrant would I be in? The fourth, right? Because there's 270 and then a little bit more past that. So this whole thing is 294 degrees. But, right, the angle that I'm looking for is always the angle between the terminal side and the x-axis. So I'm looking for this angle right here. That's the reference angle. So in this case, what math am I doing to find that reference angle? Erica, I think you had said it. Right. This time I would do 360 minus the 294 would get me that little missing angle there. So 360 minus the 294. That's going to leave me at 66. So the important thing to remember is I'm always looking for the angle between the terminal side and the x-axis. Always back to the x-axis. Now, how do you think we handle something like C, 883? And what was the vocab word for that? Do you remember? When you keep minusing 360? Co-terminal. Co-terminal, yep. So first, we'll make our lives easier and bring it down to, I get 163? So it's the same thing as a 163-degree angle, so they are coterminal. So see if you can find its reference angle. Sure. Everybody got it? What must the measure of this angle be right here? 17. In this case, I'm doing 180 minus 163. Gets me a reference angle of 17 degrees. Okay, one last one in this. Let's see if we can handle that one. Again, I'm not actually going to deal with a 1,387 degree angle. I'm going to find its coterminal angle first.
268. 27.
Is it? No.
307.
307. Or, well, I guess you could do 307, but if you happen to hit the button one more time, it's a negative 53. What quadrant am I in with either one, 307 or negative 53? You're in the fourth quadrant, right? But the reason why the negative is actually going to help me a little bit, doesn't that give me this? Right? Wouldn't that be a negative 57 down? So that angle is just a 57? Yeah, so that is your reference angle in this case. Oh, 53, I'm sorry. Sorry. I had a 7 in my head. But you could have gotten, if you did 307, right, you would just do 360 minus 307, and you're still going to get that 53. All right, cool. Easy enough? All right.